In experiment 2, part 1, we are going to measure 5 different beams. First, we need to install the beam firmly onto the mounting base. Then, measure the effective length of the beam from the edge of the fixture to the edge of the beam. After that, focus the laser to the middle edge of the beam. Make it close to the edge as close as you can. Check the settings of the vibrometer and all the connections. Now we can open the VIDlab on the computer. Close all the windows, all the windows opened, and open 2 new windows. Set one as the frequency domain, FFT, the other to the time domain. Check the other settings, follow the experiment 1. Next, go to AD settings, change the FFT averaging from off to magnitude 5. As you can see, the bottom right corner, the counter of the average has been set to 5. Now the software is ready for capturing the data. Before we start capturing the data, actually you can right-click the FFT domain, change the range of the frequency from the default value 10 kHz to, for example, 2 kHz. By changing this, later you will have a closer look at the frequency curve. Now we can click on the single shot button to start the trigger. As you can see at the corner, the trigger indicator is on now. So it's ready for capturing the data. We will use the bigger side of the hammer to hit the beam at the same spot slightly. So as you can see, I have already marked the point for the reference. After the first strike, as you can see, the waveform is generating. With the full ring down, you can see the indicator of the trigger is on again, which means the ring down is finished. It's ready for the second strike. Now this is the second strike. We can auto scale to make the curve clearer, but as you can see, this strike is not good because the first several cycles, the magnitude is too big, which means the hammer bounced back on the beam. Usually I will start a new capturing. Just stop the capturing and click the single shot again, which will start our new capturing. As you can see, the new waveform is pretty smooth. The magnitude decreases logarithmically, and there is no big magnitude at the beginning of the cycles. And you also has a complete ringing down at the end. Also, check the beginning of the waveform. Make sure there's no vibration over there, which may be caused by the vibration of the environment. Now you can see the indicator of the trigger is on again, which means you can start another strike. The second strike is also pretty smooth. The indicator of the trigger is on again, then another one. Keep each strike in the same strength, and the magnitude of each strike within 100 millimeter per second to 500 millimeter per second, then you may get a pretty decent waveform. The counter at the bottom stop counting now, which means we have finished all the 5 capturing. You can also check the single shot button. If it's colored again, it also means you finished the capturing. Next, by following the instruction, we are going to measure in the FFT domain and the time domain. In the FFT window, select the band cursor, highlight the peak, and then click Cursor Properties. Enable Damping Coefficient Zeta and Fade Curve. Setting should match the picture in the instruction. Click and drag the cursors to fit the curve to the first peak. The cursor in red will auto fit the frequency with the maximum magnitude, which is the damping frequency. Here, in time domain, the measurement will be different compared to the instruction because the version of our software is a little bit lower than it is in the instruction. So by choosing the differential cursor properties, we don't have the damped sine fade. We only have the first 3 options. As you can see in the instruction, the missing options will fit an exponential decay curve with a constant logarithmic decrement delta to the data. So here we have to use the method in the first experiment to derive all the values we need. First, we need to open a new window, set it to time domain, auto scale, click zoom in button, and draw a small square around the beginning of the signal. Use either band cursor or differential cursors to select 2 positive peaks and measure the magnitude as what we did in the first experiment. Then record the measurements. Later we will use these values to calculate logarithmic decrement delta and the decay beta. In the time domain, choose band cursor to measure the maximum velocity magnitude. Simply drag the cursors, one to the very beginning, the other to the raining down. Then the red cursor will auto fit the maximum velocity. Lastly, check all the values in the frequency domain, time domain. Record them into the spreadsheet for analyzing later. After we finish the first beam, we will change to another one, then repeat all the procedures again until we finish all the 5 beams. Now, by changing the beam back to the third one, we will start the second part. So we need to first disable the averaging of the FFT. Then we will start the single shot again for capturing the new strikes. You can also choose continuous trigger, which means you don't have to click a single shot button every time before you want to capture a new strike. In this part, we need to perform 10 impact tests with a peak velocity magnitude in the FFT domain between 15 and 60 millimeters per second. Accordingly, in the time domain, this is from about 100 millimeter per second to 400 millimeter per second. As it was in the first experiment, we also need to go to time domain, measure two positive peak values in order to calculate beta and delta. In the final part of the video, I would like to give you some tips. Be sure to strike the same spot on the beam with the same hammer tip. I was using the bigger side of the hammer. In order to get a clean waveform, avoid the hammer bouncing on the surface of the beam. Furthermore, start a new strike after the trigger indicator is on again from the previous strike. Sometimes I will wait 2 or 3 more seconds. The other thing is, don't strike the beam too hard. As you can see here, we have very strong and high frequency signals at the very beginning. This type of a waveform will never give you a good result. Now we have another example, which is when you hit the beam too early before the previous strike finish the ring down. Following all the tips, you should get a nice, clean waveform. Thank you for watching.